Today, we will talk about absolute value functions, equality and inequality involving absolute value functions. So we'll start with what is an absolute value function. If you have fx equal to the absolute value sign, and instead of going into any complicacy, I'm just going to write the inside as inside, and it can be any expression in x, the input variable, then we call this function absolute value function. And remember, in order to understand this function, we are going to define it in a way that is like a piecewise defined function. We say the absolute value of inside equals to the inside if we know that the inside of the absolute value is greater than or equal to 0. It is equal to negative of the inside if we know that the inside is less than 0. With this definition, we are going to introduce the process of solving an absolute value equation. So if you have absolute value of inside equal to a constant, then in order to understand, we are going to determine first whether this constant is negative or greater than or equal to 0. So we say if this right hand side, this constant is less than 0, then I got a contradiction. Then it is a contradiction. And why is that? Remember, absolute values are always greater than or equal to 0. They are non-negative values. So I will go ahead and say that. I will say since absolute value, and it doesn't matter what is in inside, is non-negative. What does that tell me in the context of solving the absolute value equation? It tells me there is no solution. So we will not follow any procedure in this situation when the absolute value by itself is equal to a negative number. We will simply say there is no solution. If someone asks us to write down the solution set, our answer simply is going to be the empty set, or in notation, we will say this, a set with no elements inside, or we will say phi, and in notation that is this Greek letter. We will actually start solving the absolute value equation if we know this constant that we are talking about on the right hand side is greater than or equal to 0. So if the constant is greater than or equal to 0, we're going to use the definition of absolute value, the twofold definition, and we will say, removing the absolute value sign, the inside of the absolute value is either going to be equal to the positive constant, or it is going to be equal to the negative constant. And that will give us more than one solution depending on what this constant is. So what is our basic steps to solve absolute value equation? Well, we always start with the absolute value equation, try to make sure that the absolute value terms are the only terms staying on the left hand side of the equation. So isolate the absolute value terms and send everything else to the right hand side. Then determine whether the right hand side is a constant. If it is a constant, then determine if it is a positive constant or not. If it is positive constant, you get two-fold solution. You say inside of the absolute value, without the signs of absolute value, it is equal to the constant value on the right hand side, or inside of the absolute value is equal to negative of the constant. When we are trying to solve absolute value inequations, so this time we will talk about absolute value of whatever the inside is. Again, I do not know what is in there. It's just an expression in the input variable x. If we have greater than a constant, then I try to determine whether again this constant is positive or negative. So if the constant is greater than or equal to 0, then in order to solve, I write a twofold solution. I write inside of the absolute value is greater than this constant value, and or inside of the absolute value is less than negative of the constant value. So let me explain this second part of the solution a little better. So remember what absolute value becomes. It is either equal to inside or it is equal to negative of the inside. So if we say negative of the inside of the absolute value is greater than the constant, and we say greater because that's the inequality we are dealing with, then in order to get the inside by itself, I would have to divide both sides by -1. And what it will do for us, it will make the inside by itself. But because you are dividing by -1, the sense of the inequality is going to be switched to a less than, and you will get a negative constant. And that's why when we were writing the rule, we skipped these steps and we simply went ahead and said that either we are going to get inside is greater than the constant value, or negative of the inside is greater than the constant value, or simply inside is less than the negative constant value. So this is your twofold solution to the inequality if you have the strict greater than sign. You know we can have greater than or equal to, then I simply do in the rule greater than or equal to, and the less than becomes less than or equal to, as simple as that. Now this is all when the constant is greater than or equal to 0. What happens if this constant value is strictly greater than, is less than 0? It's a negative value. If you have this constant on the right hand side to be less than 0, then since the left hand side is the absolute value function, and you know the absolute value function is always non-negative, so I go ahead and say that since absolute value is non-negative, it is always greater than or greater than equal to a negative constant. So this is a spatial situation, and remember from linear equation we have called these situations identity situations. So what it tells you that the entire real number line is going to be solution to our absolute value equation. So it doesn't matter what is the specific value of x, absolute values are always greater or equal to a negative constant. So if your inequality is absolute value greater or equal to a negative constant, your solution is all real numbers. And there are two ways we write down this solution. Either we write negative infinity to infinity on the number line in the interval notation, or in the set notation we write r to represent all real numbers. Now this is one way of solving the absolute value inequality if the inequality was greater or equal to. What if we have the absolute value of something inside an expression in the input variable x less than a constant? Again, it depends whether the constant is non-negative or negative. If you know the constant value in this situation is less than 0, remember absolute value cannot be less than a negative number. So since absolute value can not be less than a negative number, a negative constant, we have to say this is a contradiction, because the inequality literally says that my absolute value is less than a negative constant. So it is a contradiction, which means there is no solution. Hence, the solution set for this inequality is the empty set, which we can write in two different ways. But if this constant is greater than or equal to 0, then we get twofold solutions. Or I can simply say that, let's first do it for strictly greater than 0, then we will include the equality sign. So if the constant is a positive constant, then you write twofold solution. You write inside of this absolute value is less than the positive constant, or negative inside of the absolute value is less than the constant. Those are the two definitions of the absolute value. Absolute value of inside is either inside or negative inside. So what does that tell me? It tells me I get inside of the absolute value less than the constant, and inside of the absolute value less than negative of the constant. Actually it should be greater than. And again, remember, this is the same argument that we were seeing for the greater than equal to case. If you divide both sides by -1, then the inequality sign is going to change to a greater than sign. So I will get inside of the absolute value is greater than negative of the constant. And that we can consider as the rule for solving a less than inequality when the right hand side is a constant. Now, as we have done previously, if we had less equal to, all these rules are going to still stay the same. Instead of using strict inequality, now we have to have equalities everywhere. So now we will go ahead and get our lecture note and start working on this lecture note, and hopefully it was going to give us a little better idea about the process of the solution. So I'm going to insert our lecture note for absolute value functions and equality and inequality and start working on that. Okay. So first, we are going to remind ourselves about the linear equality and inequality a little bit. That is going to help us do the absolute value equality and inequality. So this question is asking us, match the inequalities with one of the graphs below. So I have 4 different graphs and I have 4 different inequalities, and we are going to understand which inequality refers to which graph. So what I do, the first one is x less equal to 2. So what you do, you go ahead and draw this graph. And I always do the graph with the equality only. So when I have less equal to, I think about that as x equal to 2. And remember, that will be this. So this line is x equal to 2. And I want less than or equal to this line. So I should be on the left-hand side of this line. And I should be touching this line as I am less than or equal to. So this is what the inequality region obtained from x less than equal to 2. The other line is y equal to 4. It is y greater equal to 4, but I'm going to just use y equal to 4 to draw the line first. So that will be 1, 2, 3, say 4 here. So this is your line. And that is the line y equal to 4. But I want y greater equal to 4. So y should be greater than this line. So it should be upwards. So I'm going to get this direction for y greater than 4. So because these things are associated with each other by and, now I get to say that, well, we are looking for the region where we have both-sided arrows. We have the left side of the line x equal to 2 and the upper half of the line y equal to 4, which is precisely, if you think of this line and extend it. So this is the line x equal to 2, and this is the line y equal to 4, then that will be the region where both sided arrows, the left of the line and the upward direction of the line, are going to fall. So clearly, this first inequality refers to the graph given in B. So I will say this is inequality 1. Let's go ahead and do the next one. This time we are doing x plus y is less equal to 4. So this time you have only one straight line. And again, think of this as x plus y equal to 4 and draw the line. Now remember, we can write it in the standard position and we will get x over 4 plus y over 4 equal to 1, which means the intercepts, x-intercept for this line is 4, 0, and the y-intercept for this line is 0, 4. So it will be easier for us to draw the line. You will go 1, 2, 3, 4, 1, 2, 3, 4 for the two intercepts. Join these 2 points and extend it, and that will be our line x plus y equal to 4. But remember, I need less than or equal to 4. So what I will do, I will choose a point on the left side of this line, and the easier point is 0, 0, and I will choose a point on the right side of this line. So say let's choose this point over here and just for simplicity call it 6, 0. And now I do what? I use the value 6, 0 in the line. So if I do x equal to 6, y equal to 0, then I get 6 plus 0. Clearly that is greater than 4, so it doesn't work. Why it doesn't work? Because you needed less equal to 4. How about the point 0, 0? So x equal to 0, y equal to 0 is 0. That is less than or equal to 4. So this one is good. That tells me the inequality side that we want to choose is the left-hand side of this line. So when we compare this situation, we see that the graph in D is the graph for the inequality in 2. The next inequality is y less equal to negative 4. So we will work it out. And this one will be pretty simple because we are only talking about one line. So first we're going to draw the line y equal to negative 4. So this is the line y equal to negative 4. But I should be less than or equal to. So this is the region that we are choosing for the inequality region, and clearly the graph in C is that. So I will say this is the graph for the inequality in 3. And then without doing any work, we can go ahead and say that then the graph in 1A is the graph for the inequality in 4. Now we can check it as well. So remember the fourth inequality that was y plus x greater or equal to negative 1. So we can start with y plus x equal to negative 1 and do the same thing, divide both sides by negative 1 so that you get y over negative 1 plus x over negative 1 equal to 1. That's the standard form. So the x-intercept is given by negative 1, 0. The y-intercept is also given by negative 1, 0, 0, negative 1, I'm so sorry. 0, negative 1. And then we draw these points on the Cartesian coordinates. So negative 1 for y, negative 1 for x. I join these 2 points and extend the line. And I do the same thing. I take a point on the left-hand side of this line. For example, say let's take this point and call it negative 2, 0. Does not matter. Then put it back in your straight line. So if I put y equal to 0, x equal to negative 2, then I get negative 2. But I have to be, the inequality tells me I have to be greater than or equal to negative 1, which it is not. Negative 2 is not greater than or equal to negative 1. So this is a bad choice. So I will try a point on the right. Say 0, 0 is the easier point. So I will try 0, 0. And again, y equal to 0, x equal to 0 should be 0. And that is greater or equal to negative 1. So this is the correct choice, which tells me that this is my inequality region. And so this is the graph in A is the graph for inequality in 4. Okay. A little bit of word problem. So this one is telling us an elevator at a construction site has a maximum capacity of 3,000 pounds. If the elevator operator weighs 240 pounds, and each cement bag weighs 95 pounds. How many bags of cement can be safely lifted in the elevator in one trip? So because it is a word problem and I want to know how many cement bags, I will say that is my variable. So say let X be the number of cement bags. So the weight due to the cement bags, each cement bag weighs 95 pounds and you have X of them, is going to be 95x pounds. That's just the weight of the cement bags. But then remember, the elevator is also carrying the operator. So I have to add that weight, and that is 245 pounds. So the total weight in this problem should be the weight of the cement bags plus the weight of the elevator operator. And that cannot cross the maximum weight limit. So it should be less than or equal to 3,000 pounds. And then you solve this inequality. So you subtract 245 from both sides first. That gives you 95x less equal to. So 10 minus 5 is 5. 9 minus 4 is 5. 9 minus 2 is 7 and 2. And then I divide both sides by 95. So let's go to a calculator to do the rest of the work for us. So this division, I will just use a calculator. So it's 2755, and then I divide it by 95. So I get 29. And that kind of answered my question. Question asked you how many bags of cement can be safely lifted. So we'll say 29 bags of cement can be safely lifted. Question number 3 is telling us that a car travels 50 miles per hour and passes a truck traveling 5 miles per hour. How long will it take the car to be 33 mile? And it should be ahead. It's a typo, clearly ahead of the truck. So what I do, I think of this question as a linear equality. So think about this situation. This is the moment where the truck traveling at 45 miles per hour and the car traveling at 50 miles per hour are at the same point, and the car takes over the truck. So for the next 33 miles, for next certain amount of time, I want to know, say after time t, the distance between the car and the truck. So both of them are driving for time t after the car has overtaken the truck. The distance between the truck and the car should be 33 miles. And I'm going to find this time. So the simple way of understanding this problem is thinking about how much distance it will travel, the car, in t hours. So we'll say in t hours, the car travels, its speed is 50 miles per hour, so 50 times the time, miles. And in the same time, so in t hours again, the truck travels its speed is 45 miles per hour, so 45 t miles. And remember, the difference should be 33 miles. So now I will say 50t minus 33. So 50t is from the point where the car has overtaken the truck till this point where it is after t hours. Minus 33, minus this portion, should be the distance traveled by the truck in t hours, so that should be 45t. And then I solve it for the value of t. So I do 50t minus 45t, and that is equal to 33. So that means 5t is equal to 33, and I divide both sides by 5 to isolate t, because that should be my answer. It will be 6.6 hours. So that is your answer. You say after 6.6 hours, which is actually 6 hours and 36 minutes, the car will be 33 miles ahead of the truck. So that's an example where we use linear equation to solve the purpose. Example 4 is about simple interest. It says that with 5% simple interest, what is the minimum time required for $2,000 to grow to at least $2,000? So we're just going to first remind ourselves the simple interest formula. We will say the interest earned, and we denote it by the letter I, in time t years with the interest rate and we denote it by R. And just to remind ourselves, I will write down one other thing in decimal expression. So not the percentage expression. So rate of interest should be in decimal, is given by the formula, or actually I need to do one other thing, the principal I have to write it. So we'll say interest earned in time t with the interest rate of R for the investment, and we call it the principal, P, is I, the interest earned, is principal times rate of interest times t in years. So this is the simple formula. So what do you want? You want the money to grow to $3,000. So this is total. And when I say total, I mean the principal invested plus the interest. That should be $3,000. But the principal invested is $2,000. So that is going to help us understand how much interest we are wanting. When we subtract, we get interest earned is $1,000. And then I say, by the formula, 1,000 should be equal to principal invested is 2,000 times rate of interest. And remember, the rate of interest is 5%. And I'm going to change it to the decimal expression. So I divide by 100 and I get 0.05. So times 0.05, and t is what we want to know. Okay. And it said what is the minimum time required. So then I'm going to solve it for t. So first we can divide both sides by 2,000. We have to divide by 0.05 as well. So if we do so, I get 1/2 equal to 0.05t, which 1/2 is 0.5 equal to 0.05t. So now I divide both sides by 0.05. And then remember, these will cancel each other, and 0.5 over 0.05 is going to be 10. So the required time is 10 years. So we'll say a minimum time of 10 years is required. Oops. Minimum time of 10 years is required. Okay, so let's go ahead and start working on absolute value equations. So the first equality, we see that absolute value on the left-hand side is by itself. So I am just going to use the twofold solution process because the constant on the right-hand side is a non-negative constant. So we will say either 2x minus 1 is 5 or 2x minus 1 is negative 5, and then start solving. So add 1 on both sides. So you get 2x is equal to 6. Then I divide both sides by 2. So I get x equal to 3. And on the other side, add 1 on both sides, you get 2x is equal to negative 4. Divide both sides by 2, so x is equal to negative 2. So I get two solutions, and as a solution set, it should be negative 2, comma 3. Now the second example, you have absolute value of x plus 1 plus 5 equal to 3. So first, to get the absolute value by itself, I'm going to subtract 5 from both sides, and I will get absolute value of x plus 1 is equal to negative 2. But remember, your absolute value cannot be equal to a negative number. So this is a contradiction situation. And I simply say that there is no solution. Or the solution set, if I want to write the solution set, depending on the instruction, I will either say set with nothing inside, or I will simply use the Greek letter phi to answer my question. Let's go to the third example. I have absolute values on both sides. These are the problems where you can think only the left-hand side with the absolute value and let the right-hand side be by itself without the absolute value. So what I can do, I can go ahead and say that means a minus 2 is either a plus 5 or a minus 2 is equal to negative of a minus 5. So minus, and then inside parenthesis, write down a minus 5. And then solve either equation. So the first equation, I have to subtract a from both sides. And I will get negative 2 equal to 5, which is not possible. So this side of the equation doesn't give me any solution. So I just simply say no solution. But remember, there is one other part of the equation. So for that, I'm going to first distribute the minus. So I will get a minus 2 equal to minus a plus 5. I will get the minus a to the left-hand side by adding a on both sides. So I get 2a minus 2 equal to 5. Add 2 on both sides, and I get 2a equal to 7. So then I divide both sides by 2, and I get a equal to 7 over 2. And that is the only solution to this absolute value equation. So as a set, it is singleton set 7 over 2. Or you can think of that as 3.5, whichever way you prefer. My fourth absolute value equation is 4 times absolute value of 3x minus 5 plus 2 is equal to 10. So to get absolute value by itself, I'm going to subtract 2 from both sides. And I will get 4 times absolute value of 3x minus 5 equal to 8. Then I divide both sides by 4. So I get absolute value of 3x minus 5 equal to 2. Since the right-hand side is a non-negative number, I get twofold solution. 3x minus 5 is either equal to 2 or 3x minus 5 is equal to negative. Let me write this 5 one more time. 3x minus 5 is equal to negative 2. Now in order to solve, I'm going to add 5 on both sides. So I get 3x equal to 7. Then divide both sides by 3. So x is equal to 7/3. Or add 5 on both sides as well. So you get 3x equal to positive 3 this time. And divide both sides by 3. So x is equal to 1. So there are two solutions. And the solutions are 1, 7/3. We have talked about absolute value inequality. And we will just go ahead and solve these inequalities. So the first one, you have the absolute value is less than a positive number. So it's non-negative. So I will get twofold solution. And remember, I removed the absolute value signs and I said 2x plus 6 over 3 is either less than 2, and the second solution is the inside is greater than negative 2. And I solve both of them. So let's go ahead and solve it here aside. So first you have 2x plus 6 is less than 2. So multiply 3 on both sides. You get 2x plus 6 less than 6. Subtract 6 from both sides. So 2x is less than 0. The other one is 2x plus 6 is greater than negative 2. And over 3. So again, I'm going to multiply 3 on both sides so that I can cancel these, and I get 2x plus 6 is greater than negative 6. So to get x by itself, I subtract 6 from both sides. So I get 2x is greater than negative 12. I divide both sides by 2. So I get x greater than negative 6. So the first one, I had 2x less than 0, so I can divide both sides by 2, and I will get x is less than 0. Because they are associated with and, I'm going to now draw this picture on the number line. The lower number is negative 6, the higher number is 0. Because of the strictness of the inequality, both of them are open circles. This inequality says you are greater than negative 6, so you will go to the right. This inequality says x is less than 0, so you will go to the left. And the common region of the inequality is where both color arrows are present, which is between negative 6 and 0. So in interval notation, my solution is between negative 6 and 0. And because of the openness, I will get open brackets or parentheses around. That's the solution set. My next inequality is x minus 1 greater or equal to 2. Again, 2 is non-negative, so you get twofold solution. You write x minus 1 greater or equal to 2, or x minus 1 less equal to negative 2. In either situation, we're going to add 1 to solve it for x. So x is greater or equal to 2 plus 1, 3, or x is less equal to negative 2 plus 1, so negative 1. And then I do the number line. The lower number is negative 1. The higher number is 3. I have equality, so they are closed dots. Now see, x greater or equal to 3 means you are going to go to the right hand side. X less equal to negative 1 means you are going to go to the left hand side. So I have two intervals as my solution. The left interval that I have written in blue is going to be negative infinity to negative 1 closed, or I have the other inequality which is in black, and this one is the right one. So it starts at 3 closed and goes all the way to infinity. Or in other words, there is one other way you can write this solution. You can actually go ahead and write it as negative infinity to negative 1, and then use the uppercase U that stands for the union, that stands for or, and close 3 to infinity. And that will be the solution set. Okay. Our next inequality is negative 4 times absolute value of 1 minus x is less than negative 16. So we will start dividing by negative 4 on both sides to get the absolute value by itself. So I get absolute value of 1 minus x. Do not forget to change the sense of the inequality to greater than as you are dividing by a negative number. Again, see this inequality, the right hand side is a non-negative number. What tells me that it will have a twofold solution. So I will say either 1 minus x is greater than 16, or 1 minus x is greater than, less than negative 16. Those are the two ways we will write this solution. Now for both of them, what I will do, I will add x on both sides so that I don't have to deal with the negative x anymore. So if I add x on both sides, the first one will give me 1 greater than 16 plus x. The other one will give me 1 less than negative 16 plus x. Because I want to have the numbers on the same side of the equation, I am going to now subtract 16 for the first inequality. So I will get 1 minus 16 is greater than x, or For the second inequality, I will get adding 16 on both sides, 1 plus 16 is less than x. So you get negative 15 is greater than x, or 17 is less than x. And then you know we're going to do the number line. So negative 15 is the smaller number, and the larger number is 17. And then I look at the inequalities. X is actually less than negative 15. So I will go to the left, and it is a strict inequality, so open circle. This one, x is greater than 17, but strictly greater than means open circle, and I go to the right. And again, I have two interval as my solution. So if I use the union notation, I'm going to write negative 15, negative infinity to negative 15. This time you have to use the open parenthesis for the openness. Union, or you can just say or, 17 to infinity. And that is the solution set for this inequality. Now I didn't do number D because it didn't have any space there, so let's go ahead and do number D here. So this inequality is absolute value of a plus 2 plus 3 is less than 1. You want to get the absolute value by itself, so what you do, you subtract 3 from both sides, and you get absolute value of a plus 2 is less than negative 2. But remember, absolute value cannot be less than a negative number. So this is a contradiction situation. So I say it is a contradiction. Absolute value cannot be less than a negative number. It is a non-negative number, which means there is no solution to this inequality. And that tells me that the solution set is empty, or use the notation phi. That answers my question. So we'll do one word problem, and that will be it for our class today. The value of y differs from 7 by more than 3 units. What is the expression using absolute value notation? So it says the value of y differs from 7. So I just write y minus 7. But remember, the difference between y and 7 could be 7 minus y as well. So which one I use? Well, if you want to use both of them, you basically want to use the absolute value. So when I say the difference between y and 7, I mean y minus 7 in absolute value is more than, so greater than 3 units. That's the expression. So what is the value of y? Or what are the values of y? So solve this inequality. Because the right hand side is non-negative, I get twofold inequality. I get y minus 7 greater than 3, or y minus 7 less than negative 3. So for the first one, I add 7 on both sides. I get y greater than 10. The second one, I add 7 on both sides as well, but I get y is less than positive 4. So the lower number is 4, higher number is 7. Y is less than 4, so strictness means open circle, and you go to the left because y is less than 4. Y is greater than 10, again strictness means open circle, and you go to the left. So what are the possible values of y? Those are the solutions of this inequality, and those are negative infinity to 4, and remember to use open brackets, or union 7 to positive infinity. Any real number between negative infinity and 4, exclusive, so don't take 4, or any real number between 7 and infinity, again exclusive, don't take 7, can be a solution, can be a possible value for y, so that the difference between y and 7 is more than 3. So I have pretty much talked about all the problems in this section. Keep working on your homeworks. If you have questions, let me know.